So yesterday we have discussed something about how to write a first Java program and how to compile it, how to execute it, and what I can do here, what standards we follow, and all we try to see here yesterday, right? Now, so just we just recap whatever we covered yesterday. We see what. So every Java program should be written as part of a class. The class is nothing but a block where you will be writing the Java program. That is the one. And Java programs are case sensitive. So that means wherever you should use the capital letters, there you should use the capitals. Wherever you should use the small letters, definitely you should use the small letters there. So this is how we write a class. Class name, and a open brace and a close brace. And this class can have multiple blocks. So out of multiple blocks, we will have a main block where your program starts execution. So the syntax of this main method is public static void main, which takes a string arguments, right? Which takes a string arguments here. So this is how we write it, right? And this is the statement which I am going to print onto the screen. So after writing this program, so this is called as a class. After writing this program, we save this program by using a file name, right? So the file name must be .java. So I have taken the same file name. Here you can see I have taken the same file name for my class, right? So here you can see my file name is same as what my class name, print message, right? So how to compile here? So just move to the location where you have saved your file. So I have saved my file in a D location, D, not D here, E location, and in the E location I have saved my files in a folder called as online classes, right? So we use Java C to compile the source code. Now Java C takes the file name. My file name is print message.java. Once you compile your source code, you will get an intermediate file called as .class file, and this is the .class file which is the executable format of your source code, and this executable format we are going to run. So you can see here print message.class. One intermediate file is generated with extension .class, which is generated by the compiler, and this is the compiled format of your source code. We call it as bytecode, and this executable file we have, and this file will be executing by using a Java interpreter called as Java space print message. This is how we execute it, Java space print message. Now it is going to execute. It starts executing from the main method, and whatever the statements you have in the main method, they will be printed onto your screen. So this is one printing statement I have, right, and it is printed onto my screen, right? So let us write one more program, right, so that we'll see more clearly, right? I'm going to take one more program here, new, right? So public class name, right? So the class name is addition. Just I'm taking some name here. Open the class and close the class, and we need to have a main method to start execution of this program, right? And main method is not compulsory for a Java class. We'll see in what scenarios it is not compulsory. We'll see one or two examples. We'll see where it is not compulsory, but time being I'm taking like this, public static void main, again which takes a string arguments, right? And so I'm writing some variables inside this. We'll see what is the meaning of this program. We'll see int I is equals to 10, I have declared a variable and I have initialized it to 10. One more variable I am taking, int j is equals to 20. Again I have declared it as j, right? And I am going to store the result of these two, addition of these two numbers, into a third variable, like it is int result something. I'm going to store the I plus j value inside it. I plus j value, right? So what after adding these two numbers?
Sir, hello.
Hello.
Sir, this public static void main string,
Yeah,
uh, string after you have given the square bracket,
that is called as array.
but it is before args or after args?
It can be anywhere, no problem.
Anywhere, no?
Yeah, no problem.
Okay, okay, thank you.
Yeah, fine. Bye. Right. So I plus j. So I am printing the result here. So to print the result, we use a statement called as system dot out dot print ln of. Now the result is there in a variable called as result, and I would like to append some static text to it, some message to it. So whatever the message you want to append to it, we'll use double quotations. Some result is or I plus j value is, right? So this is the static text. I would like to append this static text to a value, so we use a symbol called as plus. So this is what we call as concatenation operator. Whenever you have a static text to be appended, right, to a value, this is how. So this is going to print a I plus j value is, and whatever the value you have in the result, it is going to print it. Now let us save this program with the class name. So my class name is addition. Save it with addition dot, as we discussed, extension is Java, and I'm saving this into a folder called as online classes, right? Save it. Now this is I saved my program. Now go to the location where you have saved your program. So it is already there, my cursor is already waiting there. So dir, see, there is a program called as addition.java. Now I need to compile my source code, java c addition dot java. It is compiled, and as we have discussed, when it is successfully compiled, it gives you an intermediate file called as .class file with the class name, with this name. With the class name, it is going to generate you the .class file, and this is the .class file you can see. Because my class name and file name both are same, so it is giving the same name, right? Now if you want to run this, use a java space the file name. What is the .class file name? So when you give it, you don't use .class here. Now simply press enter. Now it is giving you I plus j is 30. You can see the output there, right? So this is how we write a Java program, right? This is how we write a program. We save it and we compile and we execute. Don't think about this integers and all, which is not required for you now time being, right? So just a sample program. So just I have showed you how to write a Java program, how to save it, how to compile it, and how to execute it, right? So this is what you are going to do. This is how we write the Java programs, right? Fine. So if you see this program, whatever the programs we have, every Java program, whatever you write, it is a combination of different types of building blocks, right? So this is also a program which is a combination of different things. So first of all, we need to know what type of characters I can use inside a program, right? Simply we say them as tokens, and technically we say them as what? tokens. A token is a smallest piece of your program. Now what different tokens we use? Let's suppose if you are constructing a building, there are lots of different material we use, and each material like these materials, all materials combined together we use, right? So we construct a building. In the same way, whenever you develop a program, your program is constructed based on multiple different tokens, right? So each token has its own meaning in the language. Now we need to understand what are the different tokens we have in this program. So in the same program, our previous program, whatever we have written, we try to understand each individual separatable piece of this program, and what is the importance of each and every piece we try to understand, right? So in Java it is possible to write, right? So different types of tokens. The first tokens of your program, as I said, individual pieces, smallest piece, right? The first pieces of your program, you can have white spaces, right? So white space is also which is a part of your program, right? So generally you can give the white space by using a space bar, or we can use a tab space. So this is also a part of your program. Now if you see this program, there is a white space, lots of areas we have a white space, which is separating two different things, like two different tokens, which is separating two different tokens, I can say, which is also acts like what, which is also a part of your program, and you can use a white space like this, right? And you will have some other tokens like comments, right? So comments also you can have in your program, and it is mandatory. It is not mandatory like, but in the real-time development environments, people use the comments. There you can use three different types of comments, right? So comments are nothing but what? Some user-friendly messages we leave in a program. They are called as what? Comments. So three different type of comments you can have in your program. So like the first you can say single line comments, single line, right? So we specify with a special symbol called as, this is a symbol we use to specify single line comments, right? So there we have multi-line comments. We specify multi-line comments like backward slash star and star backward slash, like this. We use multi-line comments like this. And third, we have a special comments which are used to generate the documentation of your program. They're called as documentation comments, right? So they will be represented like backslash star, and each line will have a star like this. So in the multi-line comments, there looks like multi-line comments, but each line will have a star, right? So if you want to comment multiple lines, you can use this one. If you want to comment a single line, this one we use. If you want to comment a multiple lines, we use this one, right? So comments also part of the program, but I did not use any comments. Now if you want to use the comments like this, you can use. So this is a main method. What is this? This is a main method where your program, where Java program execution starts. Yes, Kiran. What is your doubt?
See, like, what's the difference between the multi-line and the documentation comment difference? What's the
Yeah,
difference between those two?
absolutely.
Because, like, both.
Both look similar, but multi-line comments are this one. Let's suppose if I want to comment these two lines, this is how we use it. So this is for programmers purpose. in the programming. So
Okay.
as you are a working employee, you might have know that so there will be documents which will be developed, generated, APIs,
Right.
generally we say,
Okay.
right? So once you
Yeah.
write your program, if you want to generate the document dynamically by the Java, so we write
Okay.
such kind of comments. So these comments are taken by the Java tool. There is a tool called as Java Doc, which takes these comments and generates the documentation for your program.
Okay. Okay.
API documents you might have seen, right?
What's
APIs,
that?
APIs.
APIs. Yeah. Yeah. Yeah.
Yeah, you might have. That is a documentation describing about
Right.
something about technology, predefined things, right?
Application programming interface.
Yes,
Yeah.
yes.
Something.
So if you want to generate that, we use these documentation comments.
Okay.
Yeah.
Fine.
So once we come across API, you will understand that.
Okay. Right.
Right. Fine. So that is what.
Yeah.
Guys, just if whatever the doubts you have, just make the list of the doubts. We'll see the doubts in the ending. Right. Now this is what you have. This is a main method and this is a single line comment where the Java program execution starts. Whatever you want to write, you can write, but programmer friendly messages, some meaningful messages. And while your program compiles, these messages simply ignored by your compiler. They will not be part of your dot class file. Just for some other programmers to understand what you are trying to do, we'll write this. So in the same way, if you want to comment multiple lines, like I want to comment here 2 lines, you can comment like this. And whatever you have in between these lines are commented. So they will not be part of your dot class file. They will not be considered by the compiler. Just for user programmer, for our references, for our reference, we are writing these things, right? So this is what you have. Now this is single line comments, multi-line and documentation comments we'll see in the latter. So for that you need to have some other APIs and all. You need to have some APIs idea, right? So this is what you have. Again, comments also plays the role in your programming. The third type of tokens in your program, and the most important, we call them as identifiers, right? Identifiers. So the general meaning of a identifier is a name which is used to identify something, right? So I am identified by using my name. You are identified by using your names. Like this, each and everything will be identified by a name. So in the program also, we will be writing different blocks, and each and every block will be identified by a name. So here, not only blocks, lots of things you will have in a program, and they will be identified by their names. If you see my program, there are there are some few identifiers you have here. So in simple, the names which we use in a program is called as an identifier. Right here, it can be a class name, it can be a method name, it can be a variable name. Any name which is used to identify something is called as an identifier, right? But to write these identifiers, we have some technical rules. Some syntactical rules are defined to write these identifiers, right? So the syntactical rules, we'll see these syntactical rules one by one, right? So here, the first syntactical rule is what characters are allowed. What characters are allowed inside this, right? So what special, we have lots of different lots of different characters are available for us, and what characters are allowed for us we will see, right? So just 1 second guys, I will be back. right? So what characters are allowed as identifiers? So we have different characters, right? But not all characters are allowed. So you have some alphabets, you have some numeric characters, you have some special characters, but not all characters are allowed to use as the names, right? So what characters are allowed then, right? The allowed characters are, right, so the allowed characters are capital A to Z, and as we discussed, small a and capital A are different, so small a to Z, and you have numbers like 0 to 9. These are the regular characters, and apart from this, two special symbols are allowed, that is one underscore, the other one is dollar. Only these characters are allowed. If you want to give any name, like your class name or variable name or method name, only these characters are allowed. Java will not allow you any other special characters if you want to use, right? It will not allow you any other special characters if you want to use. It will allow you to give only these names. So it should contain, whatever the name you are using, it should contain capital A to Z or small a to Z or 0 to 9, underscore and dollar. Apart from this, it will not allow you. Why it is not going to allow you? Because each and every special character, whatever you have, it has its own meaning in the language. Let's suppose if I take a plus, it is used for some other purpose. If I take a minus or divided by or multiplication, each and every special character, whatever we use, whatever we have, are having already, they are defined in the language, they have different meaning in the language. So you should not use these things. That is the one rule. So these are only the allowed characters you have. Still you have one or two syntactical rules, right? Whenever you take a name, right, the name should start with the alphabet only, right? A name should start with alphabet only. It should not start with a numeric. In simple, I can say a name should not start with a numeric. Either it can start with what? Alphabet, or it can start with these special symbols. Okay, no problem. But it should not start with a number. So if first character should be any like an alphabet or a special symbol. Once you have your first character written, then you can have what? The number. From the second character, you can have the second number. If you try to take the first character itself as a number, it raises you an error, compile time error. Your compiler will not allow you. Right? So that is the second rule we have. So a name should not start with a number. That is the second rule we have. The third rule is, right, if you see the program here, a program is combination of lots of different words also, and you cannot use all words. There are some words which are reserved for the language. The language uses some kind of words, and they are called as reserved words. So you should not have these reserved words. You cannot use the reserved words as your names, right? No, reserved words are not allowed to use as names. As in your program, you can see there are some reserved words. Public is one, class is the other one, right? Static is the one more. Like this, you have some reserved words. Again, they have already given a meaning in the programming, Java programming. So you should not use them for your names, right? So your name should not be those reserved words. Like this, you have 53 reserved words. We'll see that list later. There are 53 reserved words, and these 53 reserved words you should not use for your names. That is the third rule, right? And fourth rule is, these are the three rules, technical rules we have, right? And a special character means what? No special character is allowed means what? Space is also treated as special character. So whatever the names you are giving, you should not separate them with the spaces. It should be a single word, right? So these are the three simple rules you have. Allowed characters, those whatever you see, those are allowed characters, and it should not start with a numeric, and it should not be a reserved word, right? So these are three simple rules. Coming to the length, there is no restrictions, but for our easy usage, we'll keep the length in between 15 to 20, right? You can take a big name of like 100 characters, absolutely allowed, but it is not that much easy to use. Each time if you, whenever you want to refer it, it is very complex. So generally most possible case, like we'll take the name in between 15 to 20 characters, right? So like this we have, uh, that is not a rule, but that is the standard, right? So length, okay, absolutely you can have any length more than any number of length you can have, any number of characters you can have, but it is like 15 to 20 characters, that is the standard. And while giving the name, generally people uses, most probably people uses I, J, K, right? But such kind of names generally are, you can use, absolutely allowed, but I don't prefer to use such kind of names because they don't give any meaning. So whenever I use, right, so let's suppose instead of I, if I use value 1, if I use value 2, both are doing the same, right? Value 1 plus value 2, right? I can use I can use J, in the same place I can use value 1 and value 2. So what is the advantage you have? So these names will give you more clear picture what you want to do, right? So try to avoid such kind of not meaningful names. So whatever the names you take, try to take always the meaningful names so that it is easy for you to read and understand. So these are standards actually general, but if you take, if it is allowed, if you want, if you take any names also, IJ case, but I don't prefer, right? In the development environments, people will not prefer such kind of uh, no meaningful names. The names should be meaningful, right? So like this you have here. So this is what some rules here, and very clear that capital A is different from a small a. That is the first thing you need to keep in your mind. So these are some few identifiers we have, right? So these are some few rules we have for identifiers, right? So try to always take the meaningful names as I told you, but there are some reserved words and you should not use these reserved words as your names. Then you should know what reserved words are there, right? As I told you, there are 53 reserved words. Reserved words, there are 53 you have, right? This list I am giving based on Java 1.5, right? In the 1.7 also you have the same 53, right? In the future they may add new. This list, these 53 reserved words are available since till Java 7.0, right? So these 53 words should not be used as your names, right? So here, if you want to see the list of these 53, just I would like to open. Yes, there are 53 reserved words, and you can find these 53 reserved words list. Just 1 second. This is a preferred book. I prefer this book. It's a very good book to learn Java, right? And this is a preferred book if you want to start learning the Java. I also, you are also can easily, and you can prefer this book to learn your Java. It is a very good book for beginners. Java complete reference, right? These are the 53 keywords, whatever the list you see here. So these are the 53 reserved words, and which you should not use as your names, right? So we'll see what is this 53, what they do in the language, what is the meaning of each and every reserved word. Each and every word has a meaning in the language. It is already defined in the language, so you should not use them, right? So there are 53. Yes, right? So one here you can see enum. This is the one which is added in 1.5 of Java latest, which is added in 1.5, right? And like this one more which you have here, asset. This is added in 1.4 of Java, right? So some few keywords which are very regularly used in the programming, like you see in your program, what keywords you can identify which you have, which I have used in this program. So some of them are from here. See here, public is the one which I have used in my program. You can see one more class which I have used in my program. You can see one more here, static, which I have used in my program, and I have used void, this also in my program, right? So like this I have used few keywords, and you should not use them for your names, right? So these are 53 you have, and you should not use them for your names, right? Each keyword, each reserved word has its own meaning, right? So this is what you have here, right? So there are some used keywords, there are some unused keywords you have, right? So these are 53, and we are not going to use these 53 for your names, right? Still what you have in this program, still whatever you can find. So we have come across this, and we have come across this white space, we have come across this, and again white space. This is a name. A name within a program is called as identifier, right? So this is a name, right? Again you have different names here. Value 1, value 2, main is not a keyword, it is a name, right? String, again a name, args, again a name, result is a name, right? So this is what reserved word, int, again these are all reserved words, right? Different things you have. Still you have some other things in your program, and you have, right? Still you have some other things. You have separator. What you have? Separators. Separators are those which are used to separate, right? So example, you can see some separators there, right? So this is the one pair of separators you have, which opens and closes, opening a class or closing a class, opening a method or closing a method. And you can see this is one pair of separators you have. This is used for arrays, this is used for scopes, right? One more pair of there in your program you can see, which I have used for a main method, right? This is what these are used to define the methods in Java. Each and every separator has a meaning, right? So we have a semicolon, which is the end of statement, right? So we will come across a comma itself as a separator, right? Dot you come across as a separator. So right in my program I have used system dot out dot, again it is separating, which is separating different things here, different parts of your program. They are separating different parts of your program. So these are such kind of separators also we'll come across in a program, right? So these are all there in my program, right? So this is what opening a class defines, as we discussed, defines the boundary of your class. So this defines the main method is opened, main method is closed. So here you have separators like this is the one separator you have. These are some separators which defines the methods of your class, right? So like this you have different separators, right? Still you can identify some things here. So what is this, right? They are called as, right? So you will have some other things in your program. They are called as what? Operators. They are called as operators. So we have 4 different category of operators. They are categorized into 4 different categories. We'll discuss them, what operators you have. Just I'm listing out what categories you have for the operators. You have arithmetic operators in Java, right? So it is not only in Java. These operators you will find in each and every language. You have relational operators for comparison purpose, right? Relational operators. You have again one more category, you have logical operators, right? And these are all very common things. There are very common operators you will find. And again you have one more category, they are called as bitwise operators, right? So they works with bits. These 3 are very common used operators in the programming. Arithmetic operators like plus, minus, modulus, multiplication, divided by, right? Post increment, post decrement, compound assignment, slot mode. You have relational operators, greater than, less than, comparing purpose, equals, right? Logical operators like and, or, right? So these are the different types of operators you have. So and we use them also. These are also building blocks of your program, right? Still you have some other important things here, right? So the things here very important out of this, the data which we use in a program. The data which we use in a program is called as, technically we call them as literals. What literals are? Technically we call them as what literals? The data itself, whatever the data you want to process. So writing a program is nothing but what? Taking some data from different sources and processing the data. After processing is coming up with some kind of results. That is what a program is going to do. Any programming language. We'll take some data from different sources. We process it. We come up with some kind of solutions. And the data itself is a part of your program. And we say them as what? Literals. A literal is the data, constant data which we use in a program is called as literal. Yes, my program is having such kind of data. This is the one I'm talking about. 10 is the data which I have used in my program. It is called as a literal. 20 is the data which I have used in my program. It is called as an literal. Right? So we'll come across what? Literals also in the program, the data. So these are the 7 different building blocks you have in a Java program. So Java program contains white spaces, and you can put the white space by using space bar or tab space. A Java program contains comments simply ignored by the compiler for programmer friendly messages. A program contains what? Identifiers, the names whatever you want to use to identify a class or variable or a method, right? So there are some syntactical rules we have for these names, and you should follow them. If you don't follow the syntactical rules, it is not going to compile your program. There are 53 reserved words. These are the words which are already defined in the language, and they have their own meaning defined for them in the language, right? And you should not use them for your names. Separators, they are also part of your program. These are to identify different things very easily, right? So where the method is open, where the method is closed, right? What is a method, but what is where the statement is terminated, to identify these different things easily, which are separating parts of your program. They are called as separators. And operators, right? To write your logics and all, to process the data. If you want to write any logics and all, we use the operators, and we have 4 categories of operators like this. And the most important, the data itself. The data whatever we use in your program, we call them as what? Literals. We call the data whatever you use in a program is called as an literal, right? So there are different types of data is available, right? So this is what, now if you see your program, so this program is a complete formation of some individual pieces, and those are the different pieces we use in your program. Technically we say them as what? Tokens. Each and every one is a token. So those are the building blocks of your Java program, and by using those 7 we'll construct a Java program. Each one has its own meaning in the program, right? So this is what you have here. This is how and what are the things we use in the Java program. Those are the 7 building blocks we have, right? So this is what here. Now we'll see each and every one. We'll discuss what is the meaning of comments as we discussed. They are some user friendly messages, programmer friendly messages. We leave identifiers, names, reserved words. Now we need to discuss about these reserved words. What is the meaning of public? What is the meaning of class? What is the meaning of void? What is the meaning of static? So definitely you should know about these 53. Day by day we will be learning these few, and we need to see what these separators, which separators should be used in what area. Again we'll see them day by day. Again operators, right? We'll mostly cover in the next session, but we'll discuss this one now. Okay, shall I continue further? Do you have any doubts in this up to now? Yes guys, do you have any doubts in this? You can ask. It's fine, good, right? So the literals is very important because everywhere we come across the data, right? And the data is very important. And what type of data is allowed, right? So the constant data which we use in a program is called as a literal, and we have different types of data, and we use different types of data in the programming. It's not tens and twenties. We have different types of data, and we use different types of data in the programming. First of all, we need to understand what data we use, right? So for this, let me draw a simple diagram to demonstrate this, right? I'm going to take the help of a simple chart I'm going to draw here, right? So you can see on my screen a table, simple table I'm going to draw. But so let us try to understand what is the meaning of literals here. It's a very general. Again, this is not related to any computer science. It's very much related to our regular life. So I'm going to draw a chart here, like this is what a serial number. This is an item name. It's difficult to draw. Let me take the help of Word document so it is easy. I don't want to waste much time on this. Right, there will be a table here, not this one. Insert table. Okay, fine. Simple table I have taken here. Right. Just I'm resizing it very quickly. Right here, serial number, item name, quantity, price for each item, and total. This is something, right? I'm taking some, right? So I'm filling this 1, 2, 3. Item name, let's suppose pen, pencil, something, eraser, quantity 1, 1, 1, price 1.00, 2.00, something, right? Okay. 3 rupees, 2 rupees, 1 rupee, and quantity is 1, right? So this becomes 3 rupees, this becomes 2 rupees, this becomes 1 rupee, right? So there will be a grand total, right, for this total. Right, there will be a grand total here. This is some 6 rupees. Now by seeing this chart, what you can understand, it's a very simple chart. By seeing this chart, what you can understand here, so this is a chart which describes a bill, a stationary bill, right? So but here, that is not my intention here. So this bill contains some data. Now if you observe this data, in our regular life, this is a very common data we use. This is a very common data we use for in our regular lives to perform some kind of, to store something, right? And anything, whatever you want to do. This is a very common data we use in our regular life. So if you see this chart contains different type of data, right? That means whatever the data we use for in our regular life for calculations and all, we have categorized the data into what? Different categories for easy identification or easy understanding. Now if you see this 1, 2, 3, this first column data, we call them as some numerics, right? So this we call them as these things, whatever you see here, serial number, item name, pen, pencil, this we call as some words. In general, words we'll call them. Now we see here, we call this data as what? Floating point numbers. Whatever you see this we call as floating point numbers, right? So we have categorized the data in our regular life into different categories, and this is a very basic data we use, right? So you come across some data like some special symbols, right? We use this dollar for representing the currencies. We have Indian rupee for representing. We have different countries uses their own formats of single characters, right? So we'll come across such kind of symbols like P is for, let's suppose example, parking. So we have different data, and we categorize this data in our regular life for easy usage and easy understanding purpose. So we call as integers. In general, we call as integer numbers, we call as floating points, we call as words, nothing but technically we call them as strings, we call them as characters. Like this we have defined the data, different data, and each data belongs to what? One category, right? So these numbers belongs to a category called as integral, these numbers belongs to a category called as floating, these numbers, these are belongs to simple alphabets, we say. In the same way, coming to the programming language, they are defined. So these things are defined in the programming language in different literals. I'm talking about the data, right? So in the programming language also, the data is classified into different categories, right? So whatever the data we have, the same data, it's not different. The same data which we use in our real life, the data is taken and it is classified into what? Different categories, right? So we try to understand what categories of data we have and how it is classified, right? So in general, how many types of data we have in this chart? We have seen some different types of data: numeric data, floating points, we have characters, we have strings, and all these things are there in your programming language. Now coming to Java, the data whatever we use for regular purpose, very general data for very regular operations, so it is categorized into different categories, right? So we call them as the data which we use for integers, they are called as integral literals. They are called as what? Integral literals, right? So these are the classifications in the Java programming. We have floating point literals, right? Floating point literals we have, right? And we have again the basic data which we use for in our regular life, character literals, single characters, right? We have this is one special category we have, which is we don't use in our regular life, but which is used by each and every programming language. They are called as Boolean literals. The data literals are nothing but the data. Don't confuse by seeing these technical words, right? So these are the four different categories we have, and very important thing is we don't have string literals, but we use very regularly that string literals as basic data. But coming to Java, they are not used as basic data, they are called as different, right? So before this, actually whatever the data I'm talking about, right? So this data is classified, right? So whatever the data I'm talking about, this data is classified in Java in two categories of data, major categories I'm talking are there. First category we call as, the data is classified into two categories, right? The two categories are like this. One which is very basic is called as, one which is very basic is called as primitive data. Primitive. So whatever I discussed up to now, that is primitive only, very basic data, which we call as primitive data. This is already there in the language, and which is very natural. This is the natural data what we use in our regular life. This is called as primitive data. These are the things: numbers 1 to 3s, 1.0s, 10.0, and ABCs, right? These are all called as primitives, very regularly available and very regularly used data. And we have one more data here. This is a very important, whatever I'm drawing, right? This data we call as, apart from the data which is there in the language, which we use in the very regularly in the language, as a programmer I can also create my own data. Yes, that is what is this programming language can do for you. You can create your own data. That data is called as reference data, right? Reference data. So this is what, so this is primitive data, is simple, like ones and twos, whatever we discussed, very basic, which we use 1, 10.0, or a special symbol called as a character called as A. This is very basic, which we use very regularly in our regular life. This is called as primitive, and as it is you can use. But in this programming language, as a programmer, you can also create your own data, which is not there in your regular life. So which you want to use for your own purpose. That is called as reference data. That is called as what? Reference data. Or technically I can say what? User defined data. In this programming language we can also create our own data. That is called as user defined data, reference data. Right? So we'll come across this reference data later. Now I am talking about only primitive data. Primitive data is nothing but what? The basic data which we use everywhere in our regular life. It is called as primitive data, and these are what? Literals. What is the meaning of literals here? A literal is nothing but right here, primitive literals. So what is the meaning of primitive integer literals here? Literal is nothing but a data. Example, right? What is this? 1, 2, 10. These are all what? Literals of type integer. They are literals of type what? Integer. Now you have literals. Examples I am writing here for to easy identify examples of this category of data: 1.00, 5.00, like this you have. They are called as floating point literals. Example of this category of data which we use in our regular life: small a or anything, x. This is what we call as characters, examples, right? And booleans. This is not you have in our regular life, but in the programming languages, every programming language uses this, right? Only two possible values you have for this. That is what? True, comma, false. There is no other data. Only two values. Each and every data here, whatever you see, each and every category has a range. It may be minus infinity to positive infinity. Here also it is have some range, but this is only simple two data values you have, right? So these are the literals, different literals we have, and we use all these literals data in the program. Very basic primitive data we call as. Now how we have categorized these literals in this language, right? How we have categorized these things in our regular life, again in the programming language also they have categorized. This time I'm giving the list of these categories, right? So different data we have, and the same data which is there in the programming language also, and which is categorized into different categories. Again I'm trying to insert one more table here to clearly understand this. Right, let me delete this. Now this is a very important chart you have. Table with let's suppose I'm going to take, let me take this many number of columns. Just what data this programming language supports, just I'm describing it in a simple table format, right? Again the same story. You can find this same table in the internet. Serial number, right? So how we have categorized the data in different categories, in the same way in the programming language also this data is categorized into different categories. They are called as types of data. different types of data we have. What is the meaning of these data types? We'll see, right? And you have we'll say in regular life we say as this is, let's suppose I'm writing something category. What is the meaning of this category? Let me fill this chart, then you will understand what is the meaning of this category. So serial number, data type, category, right? Just or we take this category last. Okay, fine, let it be. Memory is a very important thing, and range is also important thing, right? Memory, range, and you will understand all these things. Definitely it's not possible to understand in a single shot. It requires some time to understand all these things. Day by day we'll see what is the meaning of these things. Just I'm giving a chart for you, right? Wrapper class. What is the meaning of wrapper class? Not required for you now, right? Okay, fine. And some example I'm going to write. Yes, this chart is enough for me. So there are 8 different types of data types we have. Eight types are like byte. This is small letters, not capital. Oh, it is giving me capital. Short. No, I can small. Int. Right? Long. Float. What is the meaning of these things? We will understand. Double. Right? Char. And what? Boolean. Category is nothing but in regular life. What we say them? We say them as integral literals. Integers. Simple. Integral literals. Right? So all these 4 are same. Integral literals. This is also same. This is also same. These are called as floating point literals. In our regular life we say as floating point numbers, right? Again, this is also same. This is characters, single characters, character literals, right? Boolean. This is, no, we don't have this in our regular life, right? Now I'm not going to categorize it, but compare, see here, one is missing, that is string. Strings are not comes under primitives. Strings are comes under user defined. That is the difference you have. In other languages, they are comes under primitive only. In other programming languages, coming to Java, strings are not treated as primitive data. Though it is very regular, which we use in our life, but it is not primitive. It is reference data or user defined. And why these many different types are there in the integral literal itself? So we have example like examples 1, 2, right, 3 are negative numbers, 0 you can have, right? Let's suppose this is negative number, any numbers, to minus infinity to what? Positive infinity. Minus 3 here, right? And you have positive numbers. In simple I can write minus infinity to positive plus infinity. This is what? All are integrals. Now, but there are 4 different types are defined in the language. Why 4? If you see this floating, the same data in our regular life we have only, we say floating point numbers, but coming to them in language we have different, right? 10.00 comma, right, something 20.00 minus 10 and positive, any positives and negatives you can take, absolutely no problem. Positives and negatives are treated here. 20.00, fine. This is called as floating. Why 2? These many categories. We say as integral data, integers. We say as floats. We say as characters, right? But in the programming language, why these 4? Why these 4 are there to represent the same integers? why these are two, why these two are there to say represent same floating values, correct, right? So again, they are differentiated along with their memories, right? So when you say a number, a literal as byte, when you say a 3 as byte, if I take my 3 variable, the data 3 as byte, it is going to occupy 1 byte of memory, nothing but 8 bits. 2 bytes of the same 10. Let's suppose I am taking 10. Now in my program, I have taken this one. If you see my program, this is the data. This is a very important thing to differentiate. This is the data and this is the type, right? So this is the data which I want to use, and in the programming language it should be defined what is its type, which type we want to have, which form of this data you want to take, because this 10 can be in any one of these forms. It can be of byte form, short form, or int form, or long form. So when you say 10 as byte form, the memory is allocated by the Java is 1 byte. When you say the 10 as short, the memory allocated by the Java is 2 bytes. When I say the same 10 as integer, the memory allocated for this is 4 bytes, nothing but 32 bits, 8 bytes, right? Now for this 4 bytes, when you say it as by float, 10.00 as float, it allocates memory as 4 bytes, 4 bytes memory. Now when you say the same 8 bytes, the memory is different. So Java uses these types. What Java is used, these are used by the programming language. Any programming language uses these types to identify how much memory a programmer wants to take for this particular variable, for particular this data. Now when I say 10 as integer, the Java takes this integer and it understands the programmer wants to take this 10, to store this 10, the programmer wants to take 32 bits, right? For this 20, the programmer wants to take 32 bits. So these types are used by the software. These types are used by the softwares, right? And to allocate the memories. Now when I say 10 as int, it is going to allocate 32 bits for me. When I say the same 10 as by long, it is going to allocate me 8 bytes. Character, yes, this is also very special here. It occupies, so for storing a single character, generally it is required 1 byte, but in Java it is 2 bytes. Coming to this, generally 1 byte is sufficient, because why 1 byte we'll see, but it is depends on the virtual machine, the range is. So when you have 1 byte of memory, nothing but 8 bits, in the 8 bits you cannot store all integers, minus infinitive, positive, infinitive. 8 bits can store only the data, right? So there are some ranges here, range of data. So in the 8 bits you can store, right, minus 128, nothing but 2 to the power of minus 2 to the power of, you can store minus 2 to the power of, right, what is it, 7 is power value, 2, don't think it is minus 27, it is wrong, it is 2 to the power of 7 2, you can store what symbol, 2, you can store positive 2 to the power of 7 minus 1. Okay, instead of writing like this, it is a bit confusing. So you can store minus 127 2 plus 128, numbers inside 8 bits. So you cannot store more than this. Right, like this, each and every variable, each and every data type has, every data type has its own memory. If I say byte, a variable, if I say data is byte, it occupies 1 byte, and the data must be in between this range. Like this short hash range, like it is generally minus 2 to the power of 15 to 2 to the power of 15 minus 1. Integer same, right? So like 2 to the minus 2 to the power of 31 to 2 to the power of 31 minus 1. Long, minus 2 to the power of 63 to 2 to the power of 63 minus 1. Like this you have different ranges, right? But characters, yes, these are very important. They have the range like 0 to 65535. The range of what? Characters. 0 to 65535. Generally these are all Unicode values. We say them as Unicode values. What range we have for Boolean then? Very interesting here. What is the data? What is the range of data you have for Boolean? This is where this is only two values you have for this Boolean, that is true and false. It's small letters. Remember here they are small letters, not capitals, right? Only these two values, no range you have for this. These are the two values which you have for range as Booleans, right? So like this, different ranges, different memories. The default values we will see later. 0 is the default value, 0, 0, 0 for this. Floats 0, 0.0, 0, 0.0. We'll see what is the meaning of this. This is empty space. And by default value for this is false. Right? So this is what here. This is the primitive data and which is categorized into these categories in the programming language. So these are the categories I can say. These are the types, categories. Why these types? Why these many 4 types I have for representing only integers? They are differentiated by using memories, how much they occupy, and the range. Right? So coming to Java, so in some other languages you have signed bits and unsigned bits. So if you want to represent negative numbers, we represent in some other way. If you want to represent in positive numbers, we represent in some other way. But coming to Java, there is no such kind of signed bits and unsigned bits. It is all signed bits only. Everything is signed. There is no unsigned integers. There is no signed integers. Everything is signed. That means it is in the same way. How we represent a 10, in the same way we represent minus 10 also. Right? So minus 10. Integer 10 and integer minus 10. In the same way we represent it. There is no other special representation you have. And the value will get 10. Why? Because what happened? Minus 10 plus 20 giving you the result as 10. So there is no signed bits, there is no unsigned bits and signed bits. Everything is signed. So like this we have, these are the different categories we have given in the programming language. Right? So here 4 categories of we have to represent in your programming language for integers, literals. Byte, short, int, long. And there are 2 categories which are given for us to represent floating point numbers, float and double. There is one category which is given for us to represent a single characters, and one category to represent 2 values, true and false. This category, these booleans, will not have any other data. Like there is no big range is there for this category, unlike other categories. Only 2 possible values, right? So these default values we'll see. And wrapper classes not required now, time being. Just this is different meaning you have, and they are capital letters, starts with byte, short, right? Integer not required actually, but I have added it. Long, float, double, we'll see this later. Character and boolean. Same, like these are classes which is there. How I have written my own class, in the same way there are some classes are there, they have different purpose. We use these things for different purpose. So this is what you have. This is the 8 different types of data you have, and we use them in these different ways, right? So this is what this is not a new thing. The data which we use in our regular life, the same data which is categorized into different categories in your in this programming language, and this you will see in each and every programming language, not in Java only, for easy usage. And they are differentiated in 2 ways. One is memory and the other one is range. These are the 2 ways this data is differentiated, right? So this is what we have. So these are all what some example data, and this is called as literals. These are the literals. In the programming, when you use the literals, we need to specify which type of data. And coming to this, so this integer, there are 4 different categories we have to represent the same integer data, and this is int is called as by default. It is called as what? By default data. This is by default in this category. What is the meaning of by default? There are 2 to represent in this, and this is called as by default. This is also one important point to be noted. This is by default in this, and this is by default in this. What is the meaning of by default? We understand, right? That means like whenever directly I use system.out.println, like whenever if I want to use, right? So I'm going to write some expression here. I'm going to write some statement here. Now when I directly add 100 plus 200, how much memory is going to allocated for this? That is the meaning. So it should be, whenever you want to operate on the data, first thing is the data must be available to your program. That means the data will be available to your program, and whatever the data which you want to use in the program, this data must be there in the memory. If the data is there in the memory, then only the data is available to your program, right? So it should store, the data should be stored in the memory first. If it is stored, then only a program can access it. And how much memory it is going to allocate for this 100 and 200? It is going to add, it is going to display the result for you, right? But how much memory it is going to allocate for this 100 and 200? Because I did not say with what is its type, right? This is the where this default types comes. So whenever Java sees such kind of integers, by default it assumes this as what? Integer, and it allocates it 4 bytes. And whenever it sees floating point numbers, it sees it treats them as doubles, and it allocates what? 8 bytes of memory for that, right? And because only you have these things, and in other data we have only one category, character or boolean. So to represent integer data, we have 4 different categories. To represent floating data, we have 2 different categories here, right? So this is what, so these are the different categories you have for primitive data, and we left with very important, that is user defined data. And most of the in the programming in the Java, whenever you write a program, that means we are going to write our own, we are going to create our own data. That is important. This primitive data is very easy to work, but coming to this, you working with this reference data is very complex. And you are writing a program is what? In most of the programs, 90% of the programs, you will be creating your own data apart from this basic data, right? So these are the 2 different types of data we have. And this is primitive data, and this is some introduction related to what? Some primitive data. Now how to use this data, what is the meaning of this data, right? We'll see in the next session, right? So do you have any doubts now? You can ask me now, right? I'm stopping the session today. We'll continue in the next session.